Yes, the first question in the topics of diode circuits, diode DC biasing. If the diodes are precised as shown in the diagram, V1 is given as minus 5 volt and V2 as 10 volt. So V1 is given as minus 5 volt and V2 is given as 10 volt. I understand precised diodes are also called super diodes. Super diodes are also called ideal diodes. Commonly, most of the people understand ideal diodes never exist. The only unfortunate thing here is, if it never exists, why should we study is the first question mark for every engineering student today. And this was many times asked in interview, if ideal diode never exists, why should we study in engineering? The only answer is, a diode behaves like an ideal through a biasing technique. The best example is, let me consider an operational amplifier, take it as minus and plus, inverting and non-inverting terminals, and this output if I connect to the diode part. Understand, see this is a sine wave, I am giving it as a 5 sine theta, and understand this is a very simple load I am connecting over here, it is nothing but 10k and this is V0, and a simple negative feedback is providing to produce a highest stability response and linearity. You know, for all positive half cycle, if I use for all positive half cycle, I think diode point of view, here operational amplifier is acting as a comparator, diode point of view. Why? Because before the diode there is no closed loop, after the diode you must consider it as a closed loop. So if I take this is a value for Vx, as it is a comparator, it can be taken as plus VCC, because the input AC is given to the non-inverting terminal. Therefore, for all positive half, as it is plus VCC, I think it is externally forward bias. I hope you know, according to the piecewise model of a diode, if a diode is externally forward bias, internally it must experience a reverse bias. Therefore, internally you must proceed with reverse bias. No condition is given, I can take it as a silicon 0.7 volt. Obviously, VCC supply will be always greater than 0.7. Therefore, diode must experience a closed path. So once diode is closed, I am so happy to say, so here diode is closed, so implies here op amp is also closed. When our op amp is closed, internally current mirror circuit will work, internally differential amplifier circuit will work. Due to the current mirror and differential amplifier, there exists a principle of virtuality called V1 equal to V2. V1 equal to V2 is called virtual principle. It is the basic principle of operational amplifier because of using differential amplifier circuit under maintenance of instrument amplifier called current mirror circuit. Therefore, if V2 is nothing but 5 sine theta, which is behaving like V1, and I understand now it is behaving like a voltage buffer, therefore it is equals to V0. Therefore, V0 equals to 5 sine theta. What it shows, for all positive half cycle, input is 5 sine theta, output is also 5 sine theta, which is equal to Vs. So what do you mean by this? Even though there is a drop of 0.7 volt of a diode, output point of view, input voltage equal output voltage, which is not at all showing any drop. Therefore, load point of view, the knee voltage drop of 0.7 is neglected, which shows the idealistic characteristic behavior of a diode. Hence, the overall response is called ideal diode. Since there is no 0.7 volt drop, hence the external voltage is not wasted in the form of heat. If it is not wasted in the form of heat, you will be getting more stability. Stability response is called precision response. This is the main reason why the overall performance is called precised diode. So my dear students, a diode D1 and D2 are given in the circuit, and he told those two diodes are precised diodes. Understand, they are not a simple diode. Each and every individual diode they have connected there are nothing but the entire circuit of operational amplifier with a diode. So due to op amp, a practical diode behaves like an ideal diode. This you need to understand clearly, then only we can proceed the word of precision or super diode. Now let us start the answer for the given question. Now see here dear, I understand this is, you told it as an ideal diode or precise diode. So anode potential and cathode potential, here also anode and cathode potentials. So directly we can say, with respect to this point of view, this minus 5 making the diode, I mean to say 5 making this D1 reverse bias, and with respect to this point of view, this 5 making the diode reverse bias. From both the ends, D1 is experiencing reverse bias either from anode potential or cathode potential. So directly I could conclude D1 is reverse bias, that is D1 acting as open. Once again I am repeating, dears, D1 anode potential experiencing 5 volt reverse bias. Don't say minus 5 volt. As you are using the word reverse bias already, don't include polarity. That is why D1 experiencing 5 volt reverse bias because it is minus, and D1 with respect to cathode it is experiencing 5 volt reverse bias because plus is given to the cathode of D1. So from both the sides we can understand D1 can be taken as an open circuit, whereas D2, no doubt this is 10 volt and that is 5 volt, a single voltage polarity can be converted, which makes the D2 none other than on circuit. We say closed circuit or a closed switch. Therefore, if I understand the circuit, my dear students, so this is a simple D2, this is 1 ohm, this is 10 volt and this is 9 ohm and this is nothing but 5 volt, and I understand this is the overall voltage. Therefore, what is V0? Current passing into 9, current passing through 9 into 9 plus 5. So if I know I understand, I get the answer. I understand both are in series circuit. In series connection, I hope I can add voltages. Therefore, the same circuit I can draw like this, my dear students. This 10 volt can be taken as higher potential, this is higher potential, and 5 volt can be taken as a smaller potential. Therefore, this is nothing but 1 ohm and it is a simple diode, and this is our 9 ohm. Right? Therefore, because in series I can add voltages. Therefore, 10 minus 5, the overall potential can be taken as 5, and this 5 is making the diode externally forward bias. As it is an ideal diode, it must experience closed path. Therefore, what is the current passing through 9 ohms is none other than 5 by 10 ampere. Right? So if I could substitute this I over there, the final result will be getting V0 is equals to 5 by 10 into 9 plus 5. You will be getting this as the final answer, and I understand the answer what we have received is considered as 9.5 volt. The final solution shows it is a 9.5 volt, and option C must be the correct answer. Thank you.